Let there be a square which has a side of length 1. Then I can use that square to build another square. On the side it would have a length 1 as well. Then along the bottom it would have a length of 1 plus 1, which is 2. And then you can do 2 plus 1, which is 3. 3 and 2 is 5, and the pattern unfolds. You can even do this at home and discover some more Fibonacci numbers. And you can keep doing this as long as you like until you end up with something that looks like this, what we often call a golden rectangle or a golden spiral inside of it. And we call it golden because of a really interesting property that it has, which is what the funky symbols at the bottom are saying. It says if you take the length of the top and you divide it by the length of the side, it's always going to be about 1.618-ish. And this was proved in the late 18th century by an astronomer called Johannes Kepler. And here's kind of what Kepler's proof looked like. He just walked down the Fibonacci sequence and started dividing numbers by the ones that came before it. And you're going to start seeing a pattern. As I go down, you'll see that the 1.6 isn't changing. And now if I keep going, the 1.61 isn't changing. And this pattern will continue. The further I go down the sequence dividing these numbers, the closer I get to this number, which is 1.618 ... And you may have encountered the ... before when you learned about irrational numbers. Think of pi. Pi was that irrational number that everybody had to learn about. I'm going to call this one phi, or the golden ratio, because that's easy to say and a lot shorter than writing an infinite number of digits.